Hey everyone, and welcome back for another deep dive. Today, we're going to be tackling something pretty ambitious, the Grand Fibonacci SMF RVS theory. And, you might be thinking, another theory. But this one is different. This one aims to be a theory of everything. It claims to explain everything from why certain atoms are stable to why galaxies rotate the way they do. And it does it all with this one really elegant idea, push-based gravity. Intrigued? I hope so.
Yeah.
We're talking about rewriting the textbooks on physics and cosmology here. And this theory even suggests this mind-blowing connection between the building blocks of life and the fundamental forces of the universe. So buckle up, because we're about to dive into some pretty mind-bending concepts here.
Yeah, what's so fascinating about this theory is that it doesn't shy away from tackling some of the biggest mysteries in physics. Dark matter, dark energy, black holes. It offers this totally fresh perspective on all of them. And it does so by introducing these two key players, subtle magnetic fields, or SMFs, and the relative vacuum of space, or RVS.
Okay, so let's break this down a little bit. I'm already curious about these SMFs. Are they like the magnetic fields that we experience, in our everyday lives, but with a twist?
Exactly. Think of SMFs as magnetic fields, but potentially operating on a whole other level. Maybe even exhibiting fractal properties.
Fractal properties, like those mesmerizing images where you see the same pattern repeating at different scale. I'm picturing like the structure of an atom mirroring the structure of a galaxy.
That's the idea. The Grand Fibonacci SMF RVS theory hinges on this concept of fractal scaling, using what's called the Fibonacci transform. It's this mathematical tool that suggests that the same patterns repeat themselves from the subatomic level all the way up to the cosmic level.
Okay, my mind is already starting to bend a little bit. So we've got these potentially fractal SMFs.
Yeah.
But they need a dance partner, right? That's where this relative vacuum of space, or RVS, comes in.
Right. The RVS proposes that what we perceive as empty space actually possesses a kind of pressure or density. It's described by a scalar field. You can imagine it kind of like air pressure. You can't see it, but it can exert a force.
So even though space looks empty, it's actually buzzing with this invisible pressure. That's a pretty radical shift from how we traditionally view the vacuum of space.
It is. And the interaction between these SMFs and the RVS is where things get really interesting. According to the theory, this interaction generates an outward push. And at large scales, this push mimics the effects of what we perceive as gravitational attraction.
Hold on, so you're telling me that instead of being pulled towards the Earth by gravity, we're actually being pushed down by this interaction happening in the vacuum of space? That's a pretty wild concept.
It might sound strange at first, but the theory claims that this push-based gravity can explain some of those cosmic puzzles that have stumped scientists for decades. Remember dark matter and dark energy? Those mysterious substances thought to be responsible for the way galaxies rotate and the accelerating expansion of the universe.
Yeah, they've always felt like placeholder terms to me. Like, we know something's going on, but we're not sure what, so we'll just call it dark something.
Well, the Grand Fibonacci SMF RVS theory boldly claims we don't need them. It suggests that the interplay of SMFs and the RVS can explain these phenomena without invoking dark matter or dark energy.
So this push-based gravity could explain why galaxies spin the way they do and why the universe is expanding at an accelerating rate. No need for these mysterious dark forces lurking in the shadows.
Exactly. The outward push from the RVS itself could be the driving force behind that accelerating expansion, and the interaction between SMFs and the RVS at the galactic level could explain those peculiar rotation speeds that led to the dark matter hypothesis in the first place.
Okay, I'm starting to see the appeal of this theory. It's like finding a single key that unlocks multiple doors, solving several mysteries with one elegant explanation.
That's a great way to put it. And doesn't stop there. The theory even delves into the world of atoms, proposing an explanation for why certain atoms are more stable than others.
Wait, so this theory connects the vastness of the cosmos with the tiny world of atoms?
It does. Have you ever heard of magic numbers in nuclear physics?
Magic numbers sounds intriguing.
They are. These magic numbers refer to specific numbers of protons and neutrons that make an atomic nucleus exceptionally stable.
So like certain combinations of protons and neutrons are like the sweet spots of atomic structure.
Precisely. And what's remarkable is that the Grand Fibonacci SMF RVS theory suggests that these magic numbers are a direct consequence of the fractal nature of the vacuum. Remember those stable points in the RVS we talked about earlier? Those points where the SMF and RVS interactions create these stable zones?
Yeah, I'm starting to see where you're going with this. Are you saying that those stable points correspond to those magic numbers that make atomic nuclei stable?
You got it. The theory proposes that these stable zones in the RVS actually dictate the allowed configurations of protons and neutrons within an atom's nucleus. leading to those magic numbers that determine atomic stability.
So the same force that's shaping galaxies and pushing the universe apart is also dictating the structure of atoms. That's a pretty mind-blowing connection.
It is. And it gets even more mind-blowing when you consider that the most common elements found in living things, carbon, hydrogen, oxygen, they tend to cluster around these magic numbers.
Hold on, are you suggesting that the same forces responsible for the large-scale structure of the universe are also intertwined with the very existence of life?
It's a profound thought, isn't it? The Grand Fibonacci SMF-RVS theory suggests this deep connection between the fundamental forces of the universe and the emergence of life. It hints that the universe might be inherently predisposed to the existence of life.
Okay, my mind is officially blown. But wait, there's more, right? This theory also takes aim at one of the most enigmatic objects in the universe, black holes.
It does. And it challenges a core aspect of our current understanding of black holes, the singularity. See, classical physics tells us that black holes collapse into this infinitely dense point, a singularity, where all known laws of physics break down.
Yeah, singularities have always seemed a bit like a cop-out to me. A way of saying, well, things get too weird here, so we'll just call it a singularity and move on.
Well, the Grand Fibonacci SMF-RVS theory offers a different perspective. It suggests that the interplay between SMS and the RVS could actually prevent a black hole from collapsing into a singularity.
So instead of an infinitely dense point of no return, what are we left with?
The theory proposes that black holes would have a finite core, a region of incredibly high but not infinite density.
A finite core, that would resolve a lot of problems, wouldn't it? Like, what happens to all the information that falls into a black hole? If there's no singularity, maybe information isn't lost after all.
Exactly. That's the black hole information paradox. And the concept of a finite core could potentially solve it.
Right.
The theory suggests that information wouldn't vanish into a singularity, but would instead be encoded within the black hole's core.
This theory just keeps getting more and more fascinating. It's challenging so many long-held assumptions about the universe. But tell me, are there any practical implications to all of this? Aside from rewriting our textbooks, of course.
Well, that's where things get even more speculative, but potentially very exciting. One of the most intriguing hypotheses arising from this theory involves aging.
Aging? You're telling me the theory about the universe and gravity could have something to say about why we age?
Remember how we talked about those magic numbers? And how certain elements are more stable than others? Well, carbon, although essential for life, isn't perfectly node-locked onto one of those magic numbers.
So carbon, the backbone of life, isn't perfectly stable at the atomic level.
Right. And the theory suggests that this slight instability in carbon could be related to the aging process. The idea is that because carbon isn't perfectly node-locked, it's susceptible to a gradual breakdown over time, which could contribute to aging.
So you're saying the same force that holds us together might also be the reason we eventually fall apart. That's a pretty profound thought.
It is, but here's where the application part comes in. The theory suggests that if we could manipulate the SMF-RVS environment, we might be able to enhance carbon stability.
Wait, are you suggesting we could potentially slow down aging?
It's a hypothetical possibility, and I want to stress that it's still highly speculative. But if this theory is correct, and we could learn to manipulate these fundamental forces, it could have massive implications for our understanding of life and aging.
Okay, that is some next-level stuff. But before we all rush out to build SMF manipulators, how do we even know if this theory holds water? What kind of evidence are scientists looking for?
That's a great question. There are a few key areas where this theory could be tested. First, the theory predicts the existence of stable, super-heavy elements heavier than any we've observed so far. Finding these super-heavy elements would be a major confirmation of the theory's predictions about the fractal nature of the vacuum and those stable zones.
So if we discover these super-heavy elements, that's a point in favor of this theory.
Absolutely. Another area is in observing the orbits of planets. The theory predicts that planetary orbits should exhibit certain fractal patterns, a cosmic echo of the fractal nature of the vacuum.
So astronomers would be looking for signs of fractal scaling in the arrangement of planets around stars.
Exactly. And finally, there's the possibility of detecting echoes from black hole cores using advanced gravitational wave detectors. Remember how we talked about black holes having a finite core instead of a singularity?
Yeah, the idea that information is trapped within a finite core instead of disappearing into a singularity.
Well, if that's true, then when matter falls into a black hole, it should create a sort of echo as it interacts with the core. These echoes could be detected as subtle distortions in gravitational waves.
So finding those echoes would be like listening to the heartbeat of a black hole and confirming that it does indeed have a heart, a finite core, rather than a bottomless pit of singularity.
That's a fantastic analogy. It would be a groundbreaking discovery that would revolutionize our understanding of black holes and lend a lot of support to the Grand Fibonacci SMF RVS theory.
Wow, this is a lot to process. We've gone from the subatomic world to the expansion of the universe, and now we're talking about potentially manipulating the very fabric of reality.
It's a lot to take in. But that's the beauty of this theory. It offers this grand sweeping vision of the universe, connecting seemingly disparate phenomena with a single elegant idea.
This has been an incredible journey so far, and we're only just getting started. We'll be back in a moment to delve even deeper into the implications of the Grand Fibonacci SMF RVS theory. Welcome back. I don't know about you, but I'm still reeling from the sheer scope of this theory. We're talking about a potential paradigm shift in how we understand the universe, and it all hinges on this radical idea of a push-based gravity. It still feels a bit counterintuitive to me. I mean, we experience gravity as this force that pulls us down, right? So how does this push-based model actually work in practice?
That's a great question, and it's natural to grapple with this concept because it challenges our everyday experience. A helpful way to visualize it is to think about how objects move in a fluid. Imagine you're in a swimming pool.
Yeah.
And you move your hand through the water.
Okay, I'm picturing it. I'm creating waves as my hand pushes through the water.
Yeah. Right. And those waves can exert a force on other objects in the pool. You can even push a beach ball across the surface just by creating waves with your hand.
I see where you're going with this. So instead of water, we're talking about the relative vacuum of space, that invisible pressure field we discussed earlier. And instead of my hand, we're talking about a planet or a star moving through this RVS.
Exactly. As these massive objects move through the RVS, they create pressure waves, just like your hand in the pool. And according to the Grand Fibonacci SMF RVS theory, it's these pressure waves generated by the interaction of the object's subtle magnetic field with the RVS that create the effect we perceive as gravity.
So instead of being pulled toward the Earth, we're being pushed down by these pressure waves in the RVS. It's a mind-bending way to think about it.
It is. But it's mathematically consistent. And as we've been discussing, offers a potential explanation for phenomena that have puzzled scientists for a long time.
And one of those puzzles is the accelerating expansion of the universe, right? Does this push-based gravity model have anything to say about that?
It does. Remember how we liken the RVS to the air inside a balloon? As the universe expands, the RVS pressure increases, pushing outwards on everything within it.
So the expansion of the universe itself is creating more of this RVS pressure, leading to even faster expansion. It's like a cosmic feedback loop.
Exactly. And this provides a really neat explanation for the accelerating expansion of the universe, without having to resort to that mysterious concept of dark energy.
It's incredibly elegant. It all comes back to this push-based gravity, this interplay between SMFs and the RVS. It's amazing how one seemingly simple but radical idea can potentially explain so much.
It speaks to the power of theoretical physics to challenge our assumptions and reshape our understanding of the universe.
So we've covered a lot of ground. Push-based gravity, fractal scaling, explanations for dark matter and dark energy, implications for atomic stability, and even a potential connection to aging. It's a lot to wrap our heads around. But I can't help but wonder, what are the bigger implications for us, for humanity? If this theory is right, how might it change our lives, our future?
That's the ultimate question, isn't it? And it's one that sparks both excitement and a healthy dose of caution. If this theory proves to be true, it would represent a fundamental shift in our understanding of our place in the cosmos. We wouldn't just be passive observers of the universe. We'd be integral participants in this grand cosmic dance of forces. We're literally made of the same stuff that's driving the expansion of the universe and the formation of stars. That's a profound realization.
It is. It's like suddenly discovering that we're not just watching the play, we're on stage, playing a part in the unfolding drama of the universe. But beyond this philosophical shift, are there any practical applications that could impact our lives more directly?
Well, as we touched upon earlier, one of the most intriguing, albeit speculative applications relates to aging. We could truly grasp and manipulate the SMF-RVS interaction, as the theory suggests might be possible, then we might be able to influence the stability of matter at a fundamental level.
Including the matter that makes up our bodies. Are we talking about potentially extending lifespan or even reversing aging?
It's a bold idea. And it's crucial to acknowledge that we're in the realm of speculation here. But if this theory holds up, and we can learn to harness these fundamental forces, The implications for our understanding of life and aging would be monumental.
It's mind-boggling to even contemplate, but let's be realistic. We're still in the very early stages of understanding this theory. We have a long way to go before we can even begin to think about those kinds of applications.
Absolutely. We're talking about potentially manipulating the fundamental forces of the universe,
Yeah.
which is a level of technological mastery we haven't even begun to approach. But even if those grand visions are far off, the pursuit of this knowledge will undoubtedly lead to unexpected discoveries and breakthroughs along the way.
It's like embarking on a grand expedition into uncharted territory. The journey itself is as important as the destination, and who knows what wonders we might find along the way.
Exactly. Imagine being able to design materials with unprecedented strength and stability, or develop medical treatments that target the very building blocks of our cells. The potential applications even beyond those related to aging are vast.
And let's not forget about energy. If we could tap into the energy of the RVS, the energy that's driving the expansion of the universe, well, that would revolutionize our world. We could potentially solve so many of our energy challenges.
It's a tantalizing prospect. And the Grand Fibonacci SMF RVS theory, if proven correct, opens up entirely new avenues for energy generation, potentially leading to clean and virtually limitless sources of energy.
It's incredible to think about the possibilities, but for now we need to focus on understanding the theory itself, testing its predictions, and seeing where the evidence leads us.
Right. It's a journey of exploration, and we're just taking the first steps.
And speaking of exploration, let's circle back to one of the most captivating aspects of this theory. Its explanation for the stability of atoms. Those magic numbers we talked about earlier, those specific numbers of protons and neutrons that make atoms exceptionally stable. They're like the cosmic building codes that determine which atomic structures are allowed to exist.
Precisely. And what's remarkable is that the Grand Fibonacci SMF RVS theory suggests that these magic numbers arise directly from the fractal nature of the vacuum itself.
So those stable points in the RVS, those node solutions, dictate the allowed configurations of protons and neutrons within an atom's nucleus, leading to those magic numbers that determine stability. It's like those stable nodes are acting as templates for atomic structure.
That's a great way to think about it. And remember, those same stable nodes, just at different scales, also explain things like planetary orbits and even the large-scale structure of the universe. It's a truly unifying concept.
It really is. But what I find particularly fascinating is that the theory also explains why some elements like carbon are stable enough to exist. Even though they're not perfectly aligned with one of those magic number sweet spots, it's like they're close enough to a stable node in the RVS to hang in there, but they're not perfectly locked in.
That's right. They're in this delicate balance. And the theory suggests that this slight instability, this off-center positioning relative to a stable node, might be what makes these elements so interesting. And in the case of carbon, so crucial for life as we know it.
Okay, I'm intrigued. How does that work? How can a slight instability be beneficial?
Think of it this way. If an element is perfectly stable, perfectly node-locked, it's not going to interact with anything else, its content in its stable state.
Right. It's like the cosmic equivalent of a hermit, perfectly content in its solitude.
Exactly. But elements that are slightly off-center, like carbon, have a bit more energy, a bit more wiggle room, so to speak. They're more likely to interact with other elements to form bonds and to create more complex structures.
Ah, so it's like a social butterfly, eager to connect and form relationships.
That's a great way to put it. And that, in essence, is the basis of chemistry and ultimately life itself. The complexity and diversity of life arise from the ability of atoms to interact and form bonds.
So you're saying that life as we know it is possible because carbon isn't perfectly stable, because it has this inherent wiggle room that allows it to form the complex molecules essential for life.
That's the idea. It's another example of the elegance and interconnectedness of this theory. The same forces that shape galaxies and dictate the stability of atoms also play a role in the very existence of life.
It's mind-blowing, but of course there's another side to this coin. This slight instability in carbon might also be what makes us susceptible to aging.
You're right. As we discussed earlier, the theory suggests that because carbon isn't perfectly node-locked, it's susceptible to gradual breakdown over time, which could contribute to the aging process.
So our very existence and our eventual demise are both tied to this delicate cosmic dance of forces, this interplay between stability and instability. It's a profound thought.
It is, and it underscores the deep implications of this theory. It's not just about understanding the universe, it's about understanding ourselves, our place in the cosmos, and the forces that shape our very being.
This deep dive has been a roller coaster of mind-bending concepts and awe-inspiring possibilities. We've covered so much ground. from the tiniest atoms to the vast expanse of the universe. And it's all connected by this one elegant theory. It's incredible to think about the sheer scope of this theory, from the smallest particles to the largest structures in the universe. But beyond the science, it's those kind of like philosophical questions that really capture my imagination. Like, if the Grand Fibonacci SMF-RVS theory is right, what does it tell us about our place in the cosmos? Are we just these tiny specks of matter caught in this grand cosmic dance of forces? Or do we actually have a role to play in shaping the destiny of the universe?
Yeah, that's a profound question, and I don't think there's like a simple answer to that. This theory, if confirmed, would certainly challenge us to kind of rethink our understanding of ourselves and our relationship to the universe. We wouldn't just be observers, we'd be active participants, woven into the very fabric of reality. And that raises all sorts of really fascinating questions about, consciousness, free will,
Yeah.
and the nature of existence itself.
It's a lot to ponder. But even if those grand philosophical questions remain open, the potential for practical applications is incredibly exciting. Imagine a world where we could manipulate SMFs to create materials with properties we can only dream of today. Materials that are lighter, stronger, more durable, even self-healing.
The possibilities are pretty much endless. And let's not forget about energy. If we could tap into the energy of the RVS, we could potentially solve our energy crisis and usher in a new era of clean, sustainable energy. It sounds kind of like science fiction. But the fact that we're even considering these possibilities is a testament to the power of human ingenuity and the transformative potential of scientific exploration.
Yeah, it's a reminder that the pursuit of knowledge is never a wasted effort.
Yeah.
Even if it doesn't lead to the outcomes that we initially envisioned, the journey itself is filled with, discoveries and breakthroughs pushing the boundaries of what we thought was possible.
Exactly. And that's why it's so important to support scientific research and encourage curiosity and a sense of wonder about the universe. The Grand Fibonacci SMF-RVS theory is just one example of how a single idea can spark a revolution in our understanding of reality.
It's a reminder that we're constantly learning, constantly evolving our understanding of the world around us, and who knows what other mind-blowing theories and discoveries await us in the future.
Yeah, the universe is full of mysteries, and each new discovery opens up more questions, leading us deeper down the rabbit hole of knowledge. It's a never-ending journey of exploration.
And that's what makes it so thrilling. We're constantly pushing the boundaries of what we know, venturing into uncharted territory, and challenging ourselves to think differently.
It's like we're explorers setting sail for unknown lands, fueled by a thirst for knowledge and a sense of adventure.
Well said. And as we wrap up this deep dive into the Grand Fibonacci SMF-RVS theory, we want to leave you with a final thought to ponder. If everything in the universe, from the smallest particles to the largest galaxies, is interconnected by these fundamental forces, does that mean that consciousness itself is also part of this cosmic web? Is there a deeper connection between our minds and the fabric of reality than we ever imagined? It's a question that might not have a definitive answer, but it's certainly worth exploring.
It is. It's a reminder that there's still so much we don't know, so much to discover and understand. And that's what makes the journey of scientific exploration so exciting.
Thanks for joining us on this incredible adventure, listeners. Until next time, keep questioning, keep exploring, and keep wondering.